All right, let's just do a little math just to make sure we understand all these equations. So I'm just going to review. If we were in class, we would have done all this together, but we're not. So, okay, S equals R theta. You take the time derivative of both sides. You get ds dt equals r d theta dt. And that's the same thing as saying v, or v tangential if you want, equals r omega. Okay. Now, what I want you to do is take the time derivative of that. So you have d dt of v equals r omega. So you get dv dt equals r d omega dt. Again, we don't have to take the derivative of r because it's constant. All right? Okay, so what's dv dt? It's a. R is r, and what's d omega dt? It's alpha, right? Alpha. So that's the equation that relates the linear acceleration to the angular acceleration. All right? So, and again, if you want to put a t here, go right ahead. All right, so a sub t equals r alpha. Okay? Now, again, we're just reviewing. So for linear motion, we have x, v, and a. What's the angular version? Theta, omega, and alpha, right? Yeah, right? Theta, omega, and alpha. Again, Greek, because they're angular. Now, here's what is absolutely beautiful. So I asked you to memorize the three kinematic equations, right? Here they are. Now, there has to be, angular versions. But here's a beautiful thing. If you have these three memorized, you can get these three without doing hardly any work at all. It's simple. What's the angular version of v? Omega. V, omega. Angular version of a, alpha. Bingo! Angular version of x, theta. V, omega. A, alpha. Ta-da! Okay? V, omega. V, omega. A, alpha. X, theta. All right? So if you know these three, you know these three. It's as simple as that. Isn't that great? So you don't have to memorize these three. Just put, if you need them, just write this down and just replace the variables. That's all you need to do. It's wonderful. Or just do this in your head, right? Just say it in your head and just write it down. All right? So it's wonderful. You just replace variables. It's totally awesome. Okay, now there's one little weird thing. Okay, so I always like to use these, right? Because I have these three memorized. So then I just do what I just said. I just replace the variables. So these are all linear variables, and these are all angular variables. However, Randy Knight, the author, sometimes he likes to mix the linear with the angular, which I think is weird. But, he wrote the book. He's a smart guy. He can do whatever he wants to do. Okay, so he says, okay, so A equals R alpha. So that means that alpha is A divided by R. So sometimes instead of putting alpha, he'll put A divided by R. See? Okay? So if you see these equations in the book, don't go crazy. It's just linear with angular. But that's all he does. He just uses this to solve for the alpha. Okay? So there you go. Whatever. All right. Oh my gosh, look at all these equations we learned this chapter. Crazy, right? So, these are the four projectile motion equations. Here's the Galilean relativity, that really cool thing. Here's all the linear stuff. The angular stuff, right? Here's the period. Here's centripetal acceleration. Here's tangential acceleration, right? And here's the three kinematic equations with angular. But it looks like a lot, but it's not. But you better know everything here, You certainly better know everything there. Okay, here's a good question for you. As an object speeds up along the circular path shown below, its total acceleration points where? So please pause your video and figure it out. All right, now look. What did we learn? We learned that the A sub c always points towards the center. And we learned that the V always is perpendicular. Right? Okay. So if the V is perpendicular, all right, so here we go. All right, so look at it. As the object speeds up along the circular path, okay, so the A tangential, remember tangential, right, is going to be either this way or this way. Agree? So therefore, let's say it's this way. So if that's A sub t, this is A sub c, where's the A? So then you're just, adding vectors. So do it the parallelogram method. A would be that way. If the A sub t is this way, do the parallelogram method, and A would be that way, right? Okay, so what do you say about this? None of the above, right? None of the above, okay? It's completely ridiculous, all right? It always has to point, either like that or like that, okay? All right. Oh, boy. This is a relative motion problem. And I don't know, I kind of think this is a hard one. I don't know, in my opinion. So everybody read it while I'm erasing, please. All right, the compass of an airplane indicates that it's pointed due north. So the plane is really going north. But in the airspeed indicator, the airspeed indicator shows that it's moving through the air at 240 kilometers per hour. But there's a wind of 100 kilometers per hour from the west to the east. So we want to know what's the velocity of the plane relative to the Earth. Ooh, my goodness gracious. All right? So this is all right. Okay, so here we go, right? So here's the picture, right? All these crazy things. Velocity of the plane relative to the air, 240 kilometers per hour north. The velocity of the air relative to the Earth, 100 kilometers per hour this way. And this is the velocity of the plane relative to the Earth. Well, look at, when in doubt, just use that nutty formula that always works, all right? It will always work. So what do we want? We want the velocity of the plane relative to Earth. Okay. All right, here's a funny formula. P is on the left, P is on the left. Earth's on the right, Earth's on the right. These guys have to be the same. Now, what are they going to be? I mean, what do we know? We know something about the air, right? So it's going to be air. Okay? There you go. So there's a funny formula. Don't forget the vectors, all right? All right. Now, let's see. We've got to figure this out. What do we know? Well, we know that the velocity of the plane relative to the air, right? That's what the compass, the compass in the spiral, 240 kilometers per hour north. Okay, this is vectors, right? We got to make up our mind. Let's say that this is north, this is east. Let's call this I and J, just like we're always, just like, no kidding, what we always do, right? So I'm going to say that the velocity of the plane relative to the air, like it says, it's 240 kilometers per hour, and right? And it's north, so it's J, all right? Okay, now we want velocity of the air relative to the Earth. Velocity of the air relative to the Earth. It tells us, right, 100 kilometers per hour that way. So it's 100 kilometers per hour, I, right? I. Okay? So what's this? So that is 240 kilometers per hour J plus 100 kilometers per hour I. Okay? Well, they want to know, so how do we figure out, so we want to figure out the speed. I mean, that's the answer, right? I mean, well, that's the velocity of the plane relative to the Earth right there. But the problem would usually say, you know, what's the speed and what's the angle? So let's assume it says that, okay? I mean, but that is the answer. I mean, you know, it's a velocity, right? Has magnitude and direction. That's the answer. Okay, but let's figure out the speed and the direction just for fun. Okay, what's the speed? Velocity of the plane relative to the Earth, vector or magnitude. 240 kilometers per hour squared plus 100 kilometers per hour squared, square root of, and that comes out to be 260. 260 kilometers per hour. And let's do the angle. Well, what angle? I mean, they'd have to, let's do this angle, all right? Let's do this angle. So phi equals tan inverse opposite over adjacent. So it's 100 kilometers per hour divided by 240 kilometers per hour. Oops. And 23 degrees. 23 degrees. Now wait a second. Now how would you say that though? I mean, if this were a test question, how would you say that? This is north, so it's 23 degrees east of north. So 23 degrees east of north. All right? Okay. Let's see, where is that? I don't want to do that. Sorry. Oh, we're done. Sorry, we're done. Wait a minute. How can we read it? Yeah, we're done. All right. So we are done this chapter. This is a long, long chapter. I mean, we did two-dimensional kinematics, we did projectile motion, we did relative motion, we did uniform circular motion, we did non-uniform circular motion. So study this one hard. Thank you very much.